Hey guys, power's back on. It's currently 11:08 at school. It's been on for about 20 minutes now, and Wi-Fi is up and running as well. And so if you weren't able to make it to class this morning, or you had me in the afternoon and weren't able to see the lesson, I'm going to go ahead and do it on this video. It won't take super long to do today's lesson. We were going to do a lab. It's unfortunate if you weren't able to be there for class today because we kind of got hands-on with our triangles. And so let me first start by showing you our lesson plans for this week. You can see we're working with triangles today and also tomorrow. We're going to learn two important theorems about triangles today, and then talk more about triangles tomorrow, quadrilaterals on Wednesday. We'll have a review lesson on Thursday, which actually the stuff from this review lesson will be covered in today's lab. And then we have a quiz on Friday, and your quiz on Friday is going to contain stuff from all four sections: 7.1 vertical and adjacent angles, 7.2 complementary and supplementary angles, and then of course the lessons we're doing today over triangles and quadrilaterals we're doing this week, I should say. So anyways, let's get on with the lab then. So triangle lab, we're going to learn two important theorems about triangles, and the first one has to do with the angles. Okay, so let's see if I can get this to work. Let's see, start video, and I'm going to end my screen. Okay, so hopefully this works. And I'm going to turn this around so you guys can see my desk. And so I have three triangles here. And you can see the triangles are different sizes and different shapes. This one here is a right scalene triangle. This is an obtuse isosceles triangle, and this one is an acute equilateral triangle. And if you don't remember those, don't worry, we're going to talk about them today not today, but tomorrow when we do our triangles notes. Okay, so some of those words might sound familiar to you, like equilateral, scalene, and isosceles, or acute right and obtuse triangles. So here's what I'm going to do. I'm going to tear off two of my angles and place them next to the third angle in my triangle. So if we can see if we can prove something that's true about all triangles, regardless of what size and shape they have. So I'm going to see if I can set this here. Oops, that wasn't what I wanted to do. Why is my video stopped? Okay. All right, sorry about that. Okay, so I'm going to tear two of the angles off. So I'm just I got angle A, B, and C in this triangle. So I'm going to tear angles A and B off, place them next to C. So go ahead and do that. Okay. So there's my triangle now. There's angle C, and I'm going to place angle B next to angle C and angle A next to angle C. You see the torn edges are pointing outwards. And what we have here is we have this straight edge that was formed, the straight line right here. Okay, so now we move that triangle out of the way. And let me do this right triangle right here. Same thing, I'm going to tear off two of the angles. I'm going to tear off A and C. Okay, so give me a second. Okay, so I'm going to place them next to angle B with the torn edges pointing outwards. So you can actually see those letters are right next to each other now. And then what we have here is, again, another straight line. Okay, so again, this was from a right triangle. This is a completely different triangle than the one we just looked at right there. So we have another straight line that's forming. So we move these out of the way. There we go. And then I got one last triangle. I'm going to tear angle C and angle B off of this triangle. Okay, got it. And I'm going to place them next to angle A with the torn edges pointing outwards. One. There's two. And you can see again, we have another straight line that's forming. So think about that, because we kind of just discovered something important with these three triangles. A straight line or a straight angle measures 180 degrees. So what we've just discovered is if you add angle A, angle B, and angle C together, or angle B, A, and C, doesn't matter the order you add them together, but if you add the three angles into a triangle, it forms a straight angle which measures 180 degrees. All three angles in a triangle measure 180 degrees. Okay, that's the first important theorem that you guys need to get from today's lab. And so now I'm going to move these triangles out of the way, and now we're going to talk about the side lengths of the triangles. Okay, so I've got here 3 pieces of yarn. And my job is to make a triangle with these 3 pieces of yarn. Now, if you were in class today, you know, you know what's about to happen here. Okay, so I've got 3 pieces of yarn. I can't bend the yarn or curve it. I have to touch pieces end to end. And if I touch the pieces end to end, I should be able to make a triangle. Let's try to make it as straight as possible. Can't that edge going straighter, unfortunately. Okay, there we go. Meets up there. Let's pull it tight. And what we have here is a triangle. Okay. However, if I get rid of those pieces of yarn, get out of here, yarn. Where did the piece go? There we go. And I try to do it on this triangle, I'm going to see something interesting happen. Okay, so there's one side of my triangle. It's pretty long. Here's my other side of the triangle, which I'm going to put right here. And I'm going to attach it to this side of the triangle. Let's make this go straight. Actually, let's put you over here. So they're touching now. Well, what's the problem that we're going to have? Well, I can't force this piece to touch this piece without disconnecting it over here. So what we have is a triangle that cannot be a triangle. This does not make a triangle. So not every 3 side lengths can make a triangle. And what's wrong about this triangle? Why am I not able to make a triangle here, but I was able to in the last one? Well, it all has to do with how long this line, this segment of the triangle is, this side. It's too long. The pieces here are too short to connect. Now, I'm not saying you can't have a triangle that has long sides, but I am saying that if you have a triangle with one side that's too long, you're not going to be able to make the other 2 sides touch. And so you can't have a triangle anymore. Okay, so that's the other important theorem. That's called the triangle inequality theorem, which says the 2 shorter sides of a triangle, in order for them to make a triangle, they have to add up to be larger than the 3rd side. And they clearly don't add up to be longer than the 3rd side. Okay. All right. So let me go ahead and share those with you today. Those 2 theorems. Okay, here are the theorems. The triangle sum theorem. When we looked at the angles of the triangles, we said that all 3 angles have to add up to be 180 degrees. So angle A plus angle B plus angle C has to be 180 degrees. And then the triangle inequality theorem says that the 2 shorter sides of your triangle have to add up to be larger than the 3rd side. Now, I didn't tell you how long those pieces of yarn were. So today on your worksheet, I'm going to give you side lengths as numbers. Okay, so we're going to add them up and see if the 2 short sides add up to be longer than the 3rd side. So this is what will happen if they do add up to be longer than the 3rd side. For example, the 2 short sides on this triangle are 4 and 2. 4 plus 2 is 6. That's more than 5. So this will form a triangle. You can see the lines will touch right there. This is what's going to happen if the sides are too short. Here in this triangle, we have a side length of 5, and the 2 shorter sides are both 2. Well, 2 plus 2 is 4. That doesn't add up to be longer than 5. And so what happens is you get these little flippers, right? Kind of like in a game of pinball. You got the flippers, they won't touch. And so we have a line that's a segment that's too long, and the 2 other sides are too short. Remember, the 2 short sides have to add up to be longer than the 3rd side. This is what happens if the 2 small sides are exactly equal to the long side. You know, 3 plus 2 is 5. So they will touch, but look at the only time they touch right there. So the only time these 2 lines right here will touch is when they lay flat on top of the bottom side. That's not a triangle. That's just a really thick line. So it's the triangle inequality theorem because the two shorter sides have to be greater than the longest side, not equal to. Equal to does not cut it here. The two short sides have to be larger than the third side. So these are the two theorems, the triangle sum theorem and the triangle inequality theorem that we're going to use on our homework. Before we look at the homework, if you're in my period 6 class, then you didn't get the homework questions from the rest of the 7.2 notes. So we're going to look over those real quick. Okay. So this is the 7.2 homework over complementary and supplementary angles. Number 3, tell whether the statement is always true, sometimes true, or never true. If X and Y are supplementary angles, then X is obtuse. Well, to be obtuse just means you have to be bigger than 90 degrees. So you can have an angle be, 95 degrees and another angle be, let's see, 95 plus, I guess it would be 85 degrees. Would be equal to 180 if I added those together. So you could have an angle be obtuse and you could have another angle be acute. All right, so that would work. Or you could have an angle be 90 degrees and another angle be 90 degrees. Okay, they could be equal and still add up to 180 degrees. So the answer here is going to be sometimes, because they could both be 90 degrees. And if they're both 90 degrees, then you can't say that one of them is obtuse. So this would be a sometimes answer. Number 4, if X and Y are right angles, then X and Y are supplementary angles. Well, if X and Y are right angles, that means they're both 90 degrees. Does 90 plus 90 always equal 180, sometimes equal 180, or never equal 180? Because that's what it means to be supplementary. And the answer is it always equals 180. Number 5, if X and Y are complementary angles, then Y would be a right angle. Well, think about that. If Y is a right angle, what would I add to that to make it be complementary? Of course, complementary means you add up to 90. Well, if you add something on to 90, it would no longer be 90 anymore. So we have an angle that's already too big. In order to be complementary, they have to add to 90. You can't have one angle already be 90 because the other angle would have to be 0. And if you have a 0-degree angle, you don't actually have an angle at all. And so this would be never true. Okay, on number 22, which angles can be supplementary when paired with another angle, but could not be complementary when paired with another angle? So to be supplementary means they're going to add to 180 degrees. Which of these angles, if I paired it with another angle, could add up to 180, but couldn't add up to 90? Well, what would make them not add up to 90? Well, if they were already too big. So if I look at this angle here, this 89-degree angle, I could add 1 degree to that and make it equal 90. I could also add something to it to make it equal 180. So this one's out of the question because I'm looking for angles that could be supplementary, but not complementary, Okay, so 105, I like that one. I can add something to it to make it equal 180, but it's already too big. In fact, the two angles that are too big are the 105-degree angle and the 174-degree angle because they are already over 90. These 3 angles, I could add something to it to make them equal 90 and 180, and that's what the question's not asking me to do. I want just the angles that I could make supplementary, but they're too big to be complementary with another angle. Number 24, your friend says that angle LMN and angle PMQ are complementary, which means they add to 90 degrees. Is she correct? Well, when she says angle LMN, she's referring to this one, LMN. And when she says angle PMQ, she's referring to this angle here. So how in the world am I going to tell if she's right? Well, angle LMQ here forms a straight angle. Do you remember what a straight angle measures? That was really bad. Let me get rid of this. A straight angle measures 180 degrees. So, okay, so all 3 of these angles are going to be 180 degrees. But this angle here in the middle is 90 degrees. So take 180, subtract away the 90 from the middle angle, and you're left with 90 degrees, which means these 2 angles here, angle LMN and angle PMQ, have to add up to be 90. And that is exactly the definition of 2 complementary angles. So the answer here is that she is correct. She is correct. Number 25, the measures of 2 complementary angles, which means they add to 90, have a ratio of 3 to 2. what is the measure of the larger angle? Okay, so here's how I do problems like this where they give me a ratio. The fact that they're complementary means I'm looking at two angles that are going to add to 90 degrees. So I'm going to call each of these angles X. So two angles that add up to be 90 degrees. That's what it means to be complementary. The fact that they have a ratio of 3 to 2 means I'm going to put a 3 in front of this X and a 2 in front of that X. That's it. That's all that means. So now I can solve this equation to find out what X is by combining my 3X and my 2X. That'll give me 5X equals 90. And then dividing by 5, and 90 divided by 5 is 18. Now that's not the answer to number 25 because it says what's the measure of the larger angle. So which of these is the larger angle, the 3X angle or the 2X angle? Well, obviously it'd be the 3X angle. So knowing that X is 18, I'm going to plug 18 in right there and times it by 3 to figure out what it is. 8 times 3 is 24, carry the 2. 3 times 1 is 3 plus 2 is 5. This is a 54-degree angle. And of course, I can now find out what the smaller angle is too, but they only asked me to find the larger angle. Number 26. If two angles are vertical, now think about what it means to be vertical angles. If they're vertical, that means they're opposite from one another, but maybe even more importantly, that means the two angles are congruent, which means they have equal measure. Okay, they're congruent. It's a really bad looking congruent symbol. That's better. The two angles are congruent, so they're the same size. So can two angles be the same size and add up to be 90 degrees? If so, what would they be? Okay, well, think about it. If 90 degrees, if I split that 2 equal ways, that would be a 45-degree angle plus a 45-degree angle. Those two angles could be vertical because they're both the same, and they add up to 90. So 45 degrees would be the answer to the first part there. And then if two angles are vertical, what would they have to be if they were going to be supplementary? We'll take 180 degrees and split it 2 equal ways. And we kind of already talked about this. That'd be 90 degrees plus 90 degrees is going to equal 180. So they would both be right angles. So if they're both right angles, then they could be vertical in the same size, and they could also be supplementary. Okay, so those are the answers to some of the homework questions from 7.2. Just a reminder that 7.1 homework is due today by 2:30 on Big Ideas. If you were not in class today to turn in your work paper, I'll have you turn in your work paper tomorrow. But you have to turn in your 7.1 today by 2:30 because you still have the same deadline that everybody else has. Okay, so make sure you're getting your 7.1, I think I said 7.1 homework done today by 2:30. 7.2, this homework is due tomorrow at 2:30, so you can turn it in tomorrow like everybody else. Tonight's worksheet, tonight's homework that goes with our labs that we did, our equality, triangle inequality theorem, and our triangle sum theorem. Okay, is on Google Classroom, and you can download that to Notability and start working on that. Let's look at a few questions together. And number 1, it says, tell whether a triangle can have sides with the given lengths and show your work. Well, the triangle sum theorem says that the 2 small sides of a triangle have to add up to be larger than the third side. So I just have to check. What are my 2 small sides on this triangle? The 6 centimeter side and the 14 centimeter side. They have to add up to be larger than 20. So this is how I'm showing my work. I write that 6 plus 14 has to be greater than 20. Then I actually add what 6 and 14 is, which is 20, and 20 has to be greater than 20. And then I'm going to answer this with, is that true or not? Is 20 greater than 20? And the answer is no. So this will not form a triangle. In fact, this is what we talked about when you have, the only time they touch is when they're actually sitting on top of that bottom segment. So it's just one really thick line. It's not a triangle at all. Number 2, take the smallest 2 sides, which would be the 4 plus the 9. Is that greater than 9? Well, what's 4 plus 9? 13. Is 13 greater than 9? The answer here is yes. So you could make a triangle out of this. In fact, we'll learn tomorrow this is called an isosceles triangle because 2 sides are the same. So you'll do that with 3, 4, 5, and 6. Then you'll move on to the second part, which is going to have you find the missing angle measure in a triangle. And the triangle sum theorem says that if you add the 3 angles of a triangle together, it will equal exactly 180 degrees. So knowing that, for number 7, just take 180 and subtract away the 2 angles you do have. Now, if you add the 65-degree angle and the 57-degree angle together, of course, you can use a calculator for that. That's going to give you 122 degrees. So take away the 122 degrees that you already know you have, subtract it away from 180, and that's going to leave you with, let's see, 180 minus 120 would be 60 minus 2 more, 58 degrees. So it says label your answer, and that's just what it means. Label it with the degree symbol, right? Show your work by showing what you're subtracting away from 180. Number 8, all triangles have 180 degrees. Subtract away the 2 angles you already know. Now this is a right angle, so you know it measures 90 degrees. 90 plus 40 is 130. So 180 minus 130 is going to be 50 degrees. Okay, so you can try some of those other ones on your own. And then you're going to get some problems that look like this. These are almost kind of like puzzle problems or mazes. And so let me show you how you could do a problem like, say, number 12. Number 12, you're supposed to find what that missing angle is. Well, how am I going to do that with only the 2 angles that they've given me? Well, knowing my angle relationships that I've learned so far, I know that red angle right there is vertical from the 35-degree angle because they open up in completely opposite directions. And vertical angles are congruent. So I know that this angle is going to be 35 degrees. I also know that there's 180 degrees in every triangle. And so this forms a triangle right here. So take 180 minus away the 2 angles you already have. The 100 plus the 135 or plus the 35 is 135. Okay, that's going to give you 45. So we know this angle here is 45 degrees. And then to find our missing angle, we know this makes a straight line. And so these 2 angles are supplementary, which means if I do 180 and subtract away the 45-degree angle, well, of course, that's going to give me the 135 that I started with here. And you can see I get 135. So my missing angle here is 135 degrees. So you kind of have to work from one side of the problem all the way through to the other side of the problem. Okay, here's another one. This would be a really easy one. Number 13. Have to find this missing angle. Well, I know that that missing angle is vertical from this angle. So if I could find out what that angle is, I know that the vertical angle, other vertical angle is the exact same size. And so I know there's 180 degrees in every triangle. Subtract away the 50 degrees that we already have with the 30 and the 20. That's going to give you 130 degrees for that obtuse angle. So now we know this is 130 degrees. And if that's 130 degrees, so is the vertical angle opposite from it. So that would be our answer. So it's kind of like a puzzle that helps you work through and solve. And we can look more at more of these tomorrow when you guys are back here in class. Okay, let me know if you have any questions. Make sure you get 7.1 turned in today. Make sure 7.2 is ready to turn in tomorrow. And this worksheet that you guys are looking at right now, it's due on Wednesday. So have a great day.